All right, guys, real quickly here, I want to do a little review on factoring quadratics or solving, solving quadratics where different techniques are involved. Actually, this one over here is not even the one on my right-hand side. It's not even a quadratic here. But so one technique involves looking for the greatest common factor. Like on the left-hand side, these both have an x, so I'm going to factor out an x. All right, this term is going to become a 5x. The 8x will become an 8. All right, and now that it's in factored form, it's going to be kind of easy to solve for x. I just take each of these factors, all right, and I'm going to set those equal to 0. So that first one just means x equals 0. And then I'll take 5x minus 8 and set that equal to 0. And then we'll just solve this. Add 8 to both sides, and then divide by 5. So you get 8 over 5. Cool. 2 answers there. The reason I have this one lumped in here is because I'm going to use the greatest common factor trick again. This is the type that typically kind of throws people off and they forget how to do it. So I'm solving for x, and what I want to do is get all my x's over to one side. So first thing I'm going to do is move this 6x. I'll subtract it from both sides, and 10x minus 6x will give me 4x minus xy. Now on the right side, these both have an x again, so I can factor out an x. All right. So when I factor out an x, that's going to leave me with a 4 as that term and a minus y for that second term. All right, and now I'm going to divide by 4 minus y. So the 4 minus y factor was connected to the x by multiplication. So I'll divide it out. All right, and that does that. So these are going to be some little techniques that we'll reach back for whenever we're doing the harder trig equations tomorrow, or soon. I think it's tomorrow. But, let's see here. Difference of squares. For this one, 144 is a perfect square, but 24 isn't. So I can't jump right into it. But I can divide both of them by 6. So I'm going to divide this whole equation by 6. 24 is going to become 4x squared. And 144 divided by 6 is going to become 36. I think, no, I'm wrong about that. I don't think this is a difference of squares. Shoot. I thought I built it for difference of squares, but it's not. All right. So since I can't factor it, I meant to have it be 4x squared minus 36. Actually, dang, I could have even divided these by 4. But this would have factored using difference of squares. It would have been 2x plus 6 and 2x minus 6. All right. I guess what we'll do is we'll solve this equation without difference of squares. All right. I'm going to add 144 to both sides. It's going to give me 24x squared equals 144. I can divide both sides by 24. So it's going to be x squared equals 144 divided by 24. Yeah, you probably want to simplify this thing as much as you can. That'd be 72 over 12. That'd be, wait, I feel like that goes in evenly. 72 over 12. It does, doesn't it? 6? Yeah, 6. 72 over 12 just becomes 6. All right, so x squared equals 6, and then you could square root both sides. So x would equal plus and minus the square root of 6. All right. So I had just, I built this problem wrong. But over here, we have that difference of squares little factoring technique. All right. Next, I'm going to make a couple more here. These are going to be the basic factoring quadratics. Yeah. And I just remembered, yeah, I did not, this little baby equation right here, I had forgotten to set it equal to 0. But if I had set it equal to 0, The solutions, I would have done 2x minus 6 equals 0 and solve that, which would be x equals 3. And the other one, I forgot, would be negative 3. My bad. Come on, switch. There we go. All right, so I call this basic factoring, and that's because the leading coefficient there is a 1. So we're going to find two factors that multiply out to this. So it's got to be an x and an x. Then these two numbers have to multiply to 60 and somehow combine to give me 19. So I can already say that it's minus minus. All right. The plus sign here means that they are the same signs, and this one tells me that they're both negative. So for 60, you could list out the factors: 1 and 60, 2 and 30, 3 and 20, 4 and 15, and that's the set right there that's going to give you 19. Okay. And then you would set each of these factors equal to 0 and solve. Of course, you know, these are kind of basic. X would have to equal 4 in order for this factor to be 0. And in order for this one to be 0, x would have to equal positive 15. Okay. The one below it, x squared minus 2x. So this one, we're going to have different signs this time because it's a minus 48. The only way that you can multiply two numbers and get a negative is if one's negative and one's positive. All right, so I want them to combine to give me a 2. They're going to be subtracting this time. That's going to be a 6 and an 8. 6 times 8 is 48, and those will subtract to give me 2. All right. So at this point, it might be a guess and check method for you, but the sign of the bigger number. So because the middle one's a positive 2x, I know I've got to have a positive 8 here and a negative 6 there. All right, it's in factored form. I can now find my answers. X equals 6 and x equals negative 8. All right, I'm going to do some of the more difficult style quadratic equations next.